All right. Thanks, John, for the intro. I'm going to take this off because I feel like I'm blocking the screen for people. But is that better? Like, I think I was in the middle there. But yeah, so thanks for coming out. Again, sorry about the mix-up on the start time, but hopefully the event will be worth the wait. I think the lights are better with the stage lights off, but perfect, thank you. Okay, so we're going to be talking about fasting today. So, show of hands. Oh, actually, let's go to the outline first. So, what I'm going to talk about today is we're going to discuss fasting, why we as scientists are interested in fasting, what are some popular fasting protocols, what happens within our bodies when we fast. So, how do we deal with a fasting period? And then, given that this is a diabetes-related event, we will discuss how fasting impacts our blood sugar control and what does kind of the current evidence say about the therapeutic potential of fasting for blood sugar management. And then we'll end with kind of some take-home points and practical tips if you want to implement fasting into your daily lives. So now, show of hands, who here has fasted at some point in their lives? Okay, good. So as I'm sure all or most of you know then, fasting simply refers to not eating for extended periods of time. This can be abstinence from both food and water, or just food. You can still drink water. And then this is done for various reasons. It could be ritualistic, it could be spiritual. So depending on what you're trying to achieve with that fast, the fast can look a little bit different. And so fast might be, partial fasting, so you can eat a little bit of calories during the fast, or you can fast completely, and they can last from several hours to several days, as we'll see today. So human beings, you can say, are meant to fast. We've been fasting for tens and thousands of years, so fasting is kind of embedded within our genes. So our hunter-gatherer ancestors did not have constant access to food as we do today. So the ability to survive in kind of prehistoric times was dependent on the ability to function optimally in both the fed and fasted states. So this is something that I'll refer to as the metabolic switch, and we'll come back to this later. And also, human beings have been fasting for tens and thousands of years for ritualistic and religious and medical purposes. So fasting is certainly not new, but it does seem like it has gained a lot of traction in media as of late. So I was reading an article, and it said the number of books and podcasts on fasting exceed the number of scientific studies by an order of magnitude. So, there's New York Times best-selling books, there's various podcasts, Joe Rogan's, Andrew Huberman's, Rhonda Patrick's. I'm sure you're familiar with some of these names. And collectively, these people have a reach of like tens of millions of people. And unfortunately, many of the guests that these individuals have on their podcasts and in these books are not actually experts in fasting. And a lot of the stuff they're sharing is not based on scientific evidence. So that's kind of the purpose of this session today, is kind of dispel some of the myths and kind of tell you what fasting can and can't do. Okay, so as scientists, why are we interested in fasting? So studies in model organisms, so animals, yeast, flies, they show that restricting calories can actually extend lifespan, so it can make you live longer. This is obviously a very powerful observation, right? If you can extend your lifespan by 10, 20, 30%, that would be life-changing. So just to give you an example of what this looks like, so I'll turn to mice as an example to make this point, but again, this has been observed in various model organisms. When we fast mice, or when we restrict their calories by about 25 to 30% compared to what they would eat on a day-to-day basis, we see that their average lifespan increases by about 20 to 30%. Now, obviously, mice live for several years, not 6, 7, 8 decades like humans. So if you want to look at the human equivalent of this, the graph on the right here shows you this. So what we see is that even with a moderate level of caloric restriction in the blue line there, on average, this would be an equivalent to another 10, 15 years of life for an adult. So again, this kind of highlights the powerful benefits of caloric restriction and why, as scientists, we're kind of interested in studying this. Now, caloric restriction studies are quite difficult to do in humans, right? You can't follow an individual for their entire life and then see how long they live and make them restrict their calories forever. So we don't have this kind of data in humans, but there has been caloric restriction studies done in humans, the longest of which is the calorie trial. So the calorie trial was a multi-site trial in the US. So you can see calorie there stands for the Comprehensive Assessment of Long-Term Effects of Reducing Energy Intake. So this was a 2-year clinical trial where over 200 individuals, so these are healthy individuals without obesity, underwent a period of caloric restriction on a daily basis. So on average, they restricted their calories by about 12%, and what we see are these widespread benefits for almost on every organ system in the body. So things like reduced blood pressure, reduced lipids, reduced inflammation within the body, lower fat mass, improved cognition. So all these things significantly improved in these individuals after the 2-year calorie restriction period. So even though we can't directly measure lifespan extension in humans, we see that many of the various markers that are linked to living longer and healthier are improved with prolonged calorie restriction. So kind of supports some of those studies in mice, even though we can't directly measure it, but showing kind of the benefits of long-term caloric restriction. But eating less all the time is quite difficult, as I'm sure most people here will agree. As we drive home or we're walking outside, there's a fast food place on every block pretty much these days. There's social pressures, so you want to get together with your friends and family. It's kind of hard to not eat as much as you want to. And also some individuals can experience cognitive defects or side effects when they restrict their calories. And of course, most of us here probably know someone who's been hangry, so when they haven't eaten, they get a little bit angry. So this is what kind of makes continuous caloric restriction difficult, even though we just saw that it can have profound health benefits on the body. So this is where intermittent fasting comes in. So instead of restricting your calories continuously on a daily basis for years and years, intermittent fasting refers to fasting for periods of time and then breaking up those periods with periods of feeding. So you kind of switch back and forth between fasting and feeding cycles. The length of it each can vary depending on the type of fasting protocol you're following. And some of the most popular fasting protocols or intermittent fasting protocols are shown here. So first we have the alternative day feeding protocol. So as the name suggests, you kind of fast every other day. And the fast can be, a complete fast for 24 hours where you don't eat anything. Or you can have a small amount of caloric intake, so up to about 500-600 calories. So this can be ingested within a single meal or over the course of the day. And then the following day, you kind of eat as you normally would, and you alternate these fast and feeding days for the whole week. Another popular intermittent fasting protocol is the 5-2 diet. So this is similar to the ADF, but as the name implies, the 5-2 diet involves fasting on 2 days of the week, and then the other 5 days you kind of eat whatever you want as you normally would. The 2 days of fasting, they can be consecutive, meaning one after another, or they can be spread out during the week, so there's some wiggle room depending on what works best for you. And then lastly, another intermittent fasting protocol that's kind of gained popularity in recent years is the idea of time-restricted eating. So in TRE, you kind of fast on a daily basis, but the fasting window is confined to the majority of the day, whether that's 14 hours, 16 hours, and then breaking up that fasting window on a day-to-day basis is a 6 to 8 hour eating window where you kind of eat all your meals. And typically during TRE, individuals will choose to undertake their fast either before going to bed or when waking up to kind of maximize that overnight fasting window. So these are kind of the three popular intermittent fasting protocols that we widely see in popular media and the scientific literature, and the ones that I'll be talking about today in terms of blood sugar control. So before we kind of talk about fasting and these intermittent fasting protocols, we kind of have to talk about what happens to our blood sugar over the day and then how this changes when we fast. So this graph here kind of shows you what a normal day of eating would look like if you had your regular breakfast, lunch, and dinner and little snacks in between. And basically what we see are these repeated spikes of glucose over the course of the day in response to every meal, right? So you ingest a meal, your body digests it, your blood sugar goes up, and now this blood sugar has to be taken up by our various tissues so that it could be either stored or used for energy. And this is done through the hormone that many of you probably know of called insulin. So when our blood sugar spikes, insulin is released, and this allows our tissues to take up that blood glucose. Now, as you can see with these repeated spikes, what this would mean for our pancreas, which releases that insulin, is that it would have to work constantly through the day to secrete that insulin to deal with that blood glucose. And at the same time, when we kind of eat these 3 meals and various snacks in between, we can see on the orange line there that our blood fats kind of progressively go up over the course of the day. So this kind of eating pattern is fine if it works for you, but it never really gives our opportunity for our bodies to kind of break down and use the fuel that we have stored within our bodies. And we know that this kind of metabolic switching between taking up and storing the food we've eaten and breaking down and using the food that we've stored was a key aspect of survival for our hunter-gatherer ancestors. And again, when we eat like this, we don't really have an opportunity to kind of break down and use some of that fuel that's stored within our body. So now let's take a look at what happens when we fast. Okay, so this graph here is showing you a 72-hour fast. At the start, you can see that there is a meal, and then it shows you levels of glucose, fatty acids. So glucose is in the gray line, fatty acids are in the yellow line, and then ketones are in the orange line there. So most people here have probably heard of keto diets, right? So ketones are an endogenous fuel that is produced by your liver during periods of fasting as a result of fatty acid breakdown. And ketones are the reason why we can survive for many weeks and even months if needed, because ketones are the only other fuel that our brain will use other than glucose. So when glucose runs out, as would be expected during prolonged fasting, levels of ketones will increase, and there will be a switch within our brains where our brains start using ketones instead of glucose, because ketones are much more readily available during prolonged fasting. And the rest of our tissues are going to rely on those free fatty acids that are now increasing over the fast. And this is what's known as flipping the metabolic switch. Okay, so you're going from using glucose in the fed state or shortly after a meal over fats and ketones to now progressively using these ketones when glucose becomes limited. And as I mentioned, this metabolic switching was a key aspect of survival in our hunter-gatherer ancestors, but we don't really see this metabolic switching with today's diet. So this graph here is showing you what glucose and ketone levels would look like on a normal day of eating, again, when you eat the breakfast, lunch, and dinner, and various snacks in between. And we can see that we get these blips of glucose over the day, but our ketones never really go up over the course of that day. So by implementing intermittent fasting, so things like, in this graph, this is showing you the 5-2 method or the alternative day feeding, we can allow this metabolic switch to be flipped several days a week. So there will be periods where we're not eating, so our glucose will be relatively low, and to compensate for that, we will see an increase in those ketone bodies that are produced by our liver so that our brain always has something to use for energy. And then same thing when we do the TRE or time restricted eating, this metabolic switch can be flipped on a daily basis where during your fasting window every day, your body's going to rely on those ketones. And then when you're feeding, it's going to switch back to using glucose. And again, this metabolic switching is kind of critical for our bodies to function properly and for optimal metabolic health. Okay, so that's kind of what happens when we fast. Now let's get into some data. So what does the science say about blood sugar control with these intermittent fasting diets? So we'll start off by looking at the 5-2 diet. So what I'm going to do is I'm going to show you a picture of an article here. So most of the articles I'm going to discuss today are available open access, meaning that you can type in this title in Google and look this article up yourself and look at the findings for yourself. I'm just going to kind of help you kind of simplify the findings for you and highlight some key findings of those studies. So this first study, it looked at the 5-2 diet. So it compared the 5-2 diet where individuals fasted 2 days of the week and then ate whatever they want for the other 5 days, compared to a period of daily caloric restriction, so eating less every day on blood sugar control in individuals living with type 2 diabetes. It was a fairly large study, so they had 137 participants living with type 2 diabetes, and they followed either a 5-2 diet, so eating 500 to 600 calories on non-consecutive days of the week, and they compared this to eating less every day, which was a daily caloric restriction condition, eating about 1,200 to 1,500 calories a day, which some of you might realize is not a lot of calories. I could eat that in a single meal. And they did this for 1 year, and then they assessed their various indices of blood sugar control as well as their body weight. So what did they find? After a year, they found that both groups kind of decreased their HbA1c, so our glycosylated hemoglobin. So this is kind of the diagnostic criteria for type 2 diabetes. It's the amount of sugar that is stuck to our red blood cells. So after a year, they saw that both groups decreased their HbA1c levels similarly, whether they were following the 5-2 diet or the daily caloric restriction diet. Both groups also decreased their body weight, so they dropped body weight after a year, but the reduction in body weight was significantly greater in the group that was doing the 5-2 diet. So overall, what we can take from this study is that the 5-2 diet is equally effective as restricting your calories on a daily basis for improving blood sugar control in people living with type 2 diabetes. And they noted in the study that people that were following the 5-2 diet, they said that as the year went on, they found it easier to just restrict calories on 2 days of the week as opposed to the whole week, whereas people in the daily caloric restriction group indicated that it was quite hard to eat less on a daily basis. And this might be why weight loss was actually greater in that 5-2 diet group in this study. Okay, so that's the 5-2 diet. Next, we'll look at a study that involved that alternative day feeding. So this is where you eat normally as you would on one day, and then the following day, either you do a complete 24-hour fast, or you eat a very small meal equivalent to 500 to 600 calories. So the last study involved individuals with relatively well-controlled type 2 diabetes. This study involved individuals with relatively more advanced type 2 diabetes, so they were taking insulin, and this study will kind of highlight the safety of the intermittent fasting protocol for blood sugar control. But they took these individuals who had relatively poorly controlled type 2 diabetes, who were on insulin therapy, and they prescribed this alternative day feeding intermittent fasting protocols for a 12-day period. So these were about 50 individuals. They separated them into two groups. One group followed the ADF diet, and the other just followed standard care, so the normal advice you would get at a diabetes clinic to kind of eat as you normally would and exercise. And then same thing after the 3-month period, they kind of assess their HbA1c levels and their body mass, and also how their insulin dose might have changed over the course of that 12-week period. And similar to the last study, what they found was that this intermittent fasting protocol, now in the form of the alternative day fasting diet, significantly reduced their HbA1c levels. So this is good for type 2 diabetes. This means that your blood sugar is now lower, and there was also a reduction in body mass. And what was really important, that the amount of insulin dose that these people needed before they started the intermittent fasting protocol was now significantly less after the 3-month intervention. And 3 months isn't that long of a time, so it's pretty impressive to see these kind of changes with kind of a lifestyle modification. So from the study, we can kind of see that ADF, or alternative day feeding, is relatively safe. So there was no severe hypoglycemic events. Certainly there was people in the study who experienced hypoglycemia, but there was no serious adverse events in this study. And it was effective in lowering body weight and improving blood sugar control in people with insulin-treated or maybe a little bit more advanced type 2 diabetes. And again, after the 3-month period, the amount of insulin these individuals needed to control their blood sugar was significantly reduced with this alternative day feeding diet. Okay, so the last study we're going to look at on intermittent fasting protocols looked at that time-restricted eating. So now this is the diet we're going to be fasting on a daily basis for 14 to 16 hours, and you're going to separate that fasting period with 6 to 8 hours of eating. So this was a randomized clinical trial. This is kind of the gold standard in research study. So in this study, they had 75 participants with type 2 diabetes, a fairly large study. They randomized these individuals to 3 groups for a 6-month period. So the first group did the 8-hour time-restricted eating. So they ate all their calories within an 8-hour period, and then they fasted for the remainder of the 24 hours. And this group was told not to worry about how many calories they were eating within that 8-hour period. They were simply told to restrict their calories to that 8-hour window. They compared this to a daily caloric restriction group that was told to count their calories and reduce their caloric intake by about 25% over the course of the day. And then they had a third group that kind of just continued on with their daily diet and exercise habits, and they weren't given any advice on what to do over the course of this intervention. Okay, so let's look at what they found. So this graph is kind of showing you differences in various outcomes between the 2 groups. So first we see that adherence, so how well these individuals were able to follow the diet, was significantly greater in the time-restricted eating group, right? And this goes back to the idea that restricting calories all the time is difficult, but when you have to fast for a given amount of time and you can break that fast and eat whatever you want, you're better able to stick to it, and that's what they found with adherence. That was 87% in the TRE group, compared to about 68% in the group that restricted their calories all the time. And even though the group that was doing the TRE was not told to deliberately reduce their calories, they ended up eating 300 calories less per day. And again, this was greater than the about 200 calories that the group that was doing the daily caloric restriction was able to reduce. And because of this greater caloric deficit, they saw that the individuals in the TRE group experienced significantly greater weight loss. So they lost about 3.6% of their body mass, as opposed to 1.7% in the caloric restriction group. And when they compared to the control group, only the time-restricted eating group actually lost weight. So the weight loss in the caloric restriction group was not significantly different than the control group that wasn't prescribed any diet. And again, similar to the previous studies, we see that improvements in blood sugar control were largely similar between the 2 groups. So this study, kind of the main conclusions we see here is that TRE, even when you're not told to restrict calories, it's more effective than daily caloric restriction for reducing body weight in individuals with type 2 diabetes. And both TRE and daily caloric restriction resulted in similar improvements in blood sugar control. And again, this kind of highlights with the previous studies that I discussed that, these intermittent fasting diets are kind of equivalent to restricting calories for improving your blood sugar, but they seem to be a little bit easier for individuals to stick to, at least in these studies that we've discussed here. So while we're on TRE, how do you start engaging in a TRE program? So one really easy way, again, to extend that overnight fasting window is to kind of skip breakfast or just delay the first meal of the day when you wake up. I know this can be difficult for some people. Other people's, like myself, I don't have an appetite in the morning, so I just have black coffee and I go. But this is one method that you can use to extend that overnight fasting window. And this is important for people living with type 2 diabetes, because generally people with type 2 diabetes experience the highest blood sugar levels in the morning. This is something called the dawn phenomenon, where overnight your blood sugar levels kind of creep up and they kind of peak in the morning. And then also in response to the first meal of the day, individuals living with type 2 diabetes experience the largest blood sugar spike of any meal during the day. So this study we're going to look at here, it kind of looked at the impact of delaying breakfast on blood sugar levels in people living with type 2 diabetes. So they randomized individuals to 3 groups. So one group kind of ate their early breakfast at 7 a.m. as they normally would. The other group kind of delayed their breakfast a little bit to 9 a.m. And then they had a third group that delayed their breakfast even further to about 12 p.m. And then they measured their blood sugar levels in response to that meal. So as I mentioned, blood sugar spikes are greatest in the morning for people living with type 2 diabetes. So they looked at how delaying breakfast kind of impacted this blood sugar spike. And this graph here shows you the average area under the curve. So if we look at this glucose spike there, the area under this glucose spike curve is shown on the graph here. And we can see the three groups on the bottom. And what they found was that delaying breakfast by a few hours, so from 7 a.m. to 9 a.m. and then 12 a.m., resulted in significantly better or lower blood sugar spikes comparing to eating breakfast first thing in the morning as soon as you wake up. So kind of the key takeaways from this study is that if you can try and push that breakfast a little bit longer, this can increase that fasting, overnight fasting window to now 12, 14, and even 16 hours, depending on when the last meal the day before was. And this is kind of a practical way to improve blood sugar control in people living with type 2 diabetes. Okay, so in most of the studies that I've discussed so far, you've noticed that there's been weight loss. So there's no denying that many of the benefits of intermittent fasting and caloric restriction kind of depend on weight loss, and this is because if you look at the kind of pathophysiology or what goes wrong when you gain weight, we see this increase in our fat cells or adipose tissue. And when our fat cells can't accommodate all that extra calories and all that extra fat coming in, the fat ends up in other tissues where it's not supposed to be. So things like our liver, our pancreas, or muscle. And this deposition of fat in these tissues where it's not supposed to be impairs the functionality of those tissues. So this is why when you lose weight, you reduce the amount of fat in those various metabolically active tissues like your muscle, like your liver, like your pancreas, and allows them to work better. And this is why intermittent fasting protocols appear to be so effective, is that they're able to promote weight loss in perhaps a more practical manner than continuously restricting your calories, because now you're only fasting or restricting your calories within several hours or only certain days of the week as opposed to all the time. But it does appear that weight loss is an important determinant of the benefits of intermittent fasting. But are there benefits independent of weight loss? So just if anyone here is choosing to engage in an intermittent fasting protocol and you're not seeing weight loss, I don't want you to be discouraged, because there is some research showing that there are some benefits that are independent of weight loss. So in this study here, these were men with pre-diabetes. So they completed a 5-week intermittent or time-restricted eating protocol where they ate for 6 hours. So they ate here from 8 to 2 p.m. every day, and then they fasted for the remainder of the day. And then these researchers measured various outcomes related to their blood sugar control and overall health. So for this study, they were particularly interested in insulin sensitivity. So I just have to remind everyone how insulin and glucose regulation works. So when our blood sugar levels go up, we see our pancreas, our beta cells within our pancreas sense this increase in blood sugar and releases the hormone known as insulin. This insulin is going to then signal to our tissues, like our muscle tissue, to take up that blood sugar so that it can be stored or used for energy. So these researchers kind of looked at both aspects of this pathway. So they first looked at how good our beta cells in our pancreas were at sensing the increase in blood sugar and releasing that insulin, and then how good our skeletal muscle was at responding to that insulin. And both these pathways are impaired or don't work as well in type 2 diabetes. So what do they find? So first, the graph on the left here is showing you beta cell responsiveness. So how responsive are your beta cells, so the cells that produce insulin in your pancreas, to increases in blood sugar. And what they found was, sorry, I should mention this before I discuss the result. There was no weight loss in this study. So they explicitly designed the study to prevent any weight loss as a result of this intervention. So despite there being no weight loss, the function or the responsiveness of beta cells was significantly improved. So the ability of our pancreas to sense an increase in blood sugar and release insulin was significantly improved after the 5-week TRE protocol. And then the ability of our muscle to respond to that insulin and take up that blood glucose was also improved. And this, again, occurred independent of any weight loss that happened over the course of this intervention. So why was this happening? Well, we think that, you know, fasting, even if you're losing weight, it allows your beta cells in your pancreas to have these periods of rest. So if you think back to the graph where I showed you where blood sugar is constantly spiking when you eat the various meals through the day, your pancreas has to work all the time to release insulin, to deal with that blood glucose. When you're fasting, you don't get those repeated spikes of glucose, and that allows your beta cells to kind of rest and recover, and in turn, they end up working better. And at the same time, as I mentioned, they found that the muscles became more responsive to the insulin that was released. So kind of a neat study that shows you that even though most of the benefits of intermittent fasting are due to the weight loss, there are some important benefits for blood sugar control that can be achieved without any weight loss. And they also measured various other important health markers linked to kind of metabolic health, including blood pressure. And they also saw that those were significantly improved as a result of the intermittent fasting diet, again, without any weight loss. And interestingly, you know, you think intuitively that if you're fasting in the morning, you're going to be super hungry at night. They found that this early time-restricted eating window, so eating from 8 to 2 p.m. and then fasting, actually resulted in lower appetite in the evening. So that was kind of an interesting finding of the study. Okay, so that's kind of what the science says about the benefits of intermittent fasting. Now let's talk about some considerations if you're interested in engaging in any form of intermittent fasting. So first, obviously, if you're living with diabetes and you're on medications, medications may require adjustment when you begin an intermittent fasting diet. And of course, it has to be done in consultation with your physician, and some common medications that might need to be adjusted when you're fasting are listed here. So sulfonylureas, so your glipizide and glimepirides, insulin, metformin. So all these medications act to, you know, clear blood sugar from your bloodstream. And so when you're fasting and your blood sugar is already low, the additive effects of these medications is going to increase the risk of hypoglycemic events or low blood sugar. So again, something to take in consideration when you're starting a fasting protocol, and important to consult with your physician when you're doing so. And then, as I mentioned in the last study, overeating during the feeding window is always a concern, right? So when you've been fasting for a prolonged period of time, you're going to be really hungry when you break that fast. There are some practical tips that I'll share on the next slide for how you can deal with this kind of overeating issue. But that's something you have to be aware of. And because you're restricting your calories, there's always a consideration, does this impact, you know, my lean mass, my muscle strength? There isn't any conclusive research to say that, you know, intermittent fasting or any of these fasting protocols result in a loss of muscle mass or strength, but just something to be aware of. And the risk of any muscle mass or muscle quality or muscle function loss can be mitigated with the inclusion of exercise, which we already know is fantastic for blood sugar control. So resistance exercise would be particularly beneficial for kind of helping maintain any small losses in muscle mass that might occur with fasting. But really any type of exercise is gonna be good for your blood sugar control. Okay, so what are some practical tips if you want to start intermittent fasting protocol, or if you want to continue engaging in intermittent fasting? So as I mentioned, there's various different intermittent fasting protocols. You can try different ones, find what works for you. Each of the different intermittent fasting protocols have different durations of fast. You can do it on different days of the week. You can do the days consecutively, non-consecutively. So there's a lot of wiggle room and versatility in these intermittent fasting protocols. And it's important that you, if you're starting this, you kind of start fasting for short periods of time and then gradually increase those fasting windows as your body becomes more used to it. I talked about the study that showed that delaying breakfast reduces blood sugar spikes in the morning. So delaying your breakfast a little bit could be an opportunity to capitalize on that fast that you're already undergoing when you're sleeping overnight. So this could be 8 hours or so for most people. So if you delay your breakfast by 3, 4, 5 hours, now you've increased that overnight fasting window to 14, 15 hours. Maintaining hydration can help during a fast. Oftentimes when I feel hungry, I'm not actually hungry, I drink a glass of water and then I'm good. So maintaining hydration can help. Certainly having non-caloric beverages, black coffees, teas, anything like that, it'll keep you in that fasted state, but you'll feel more full and perhaps it'll help you get through that fast. So that could be another thing that you could do. And then again, to avoid overeating when you break that fast, so you're probably going to want to binge on all sorts of delicious foods, but research shows that if you eat meals that are higher in protein, you get more of a satiating effect. So you feel fuller for longer after you eat a high protein meal compared to a higher carbohydrate meal. So you might consider breaking your fast with something that's higher in protein so that you feel fuller for longer during your feeding window. So again, just a few practical tips that you can incorporate if you're interested in starting an intermittent fasting protocol or sticking to the current fasting protocol that you're doing. Okay, so just to leave you here finally with some take-home points. So we know calorie restriction is good. Hopefully I made that point at the start, but restricting calories all the time is hard. And so intermittent fasting is kind of a way to restrict your calories and experience some of those potent health benefits that we see with caloric restriction. And intermittent fasting can be implemented in various ways. So I talked about 3 diets, the 5-2 diet, alternative day feeding, and time-restricted eating. And even within each of these diets, as I mentioned, there's a lot of wiggle room for how long you want to fast, when you want to fast, so on and so forth. And then clinical studies that I discussed today. So relatively short-term studies lasting only 3 months, 2 long-term studies lasting up to a year demonstrate that intermittent fasting using all 3 of these protocols can help reduce body weight and improve blood sugar control in people living with type 2 diabetes. And then as I mentioned, many benefits of intermittent fasting do appear to be driven by that weight loss that occurs as a result of these diets. But as I highlighted in that last study, there are several important metabolic benefits that occur even without weight loss. All right, thank you all for coming, and I'll take any questions now. Oh.
Thank you, Hashim. That was awesome. I forgot to mention at the start, with our new grant money, we were able to purchase a tripod, and we're filming this, and it will be available for free after. So if you did come in a little bit late, or you didn't catch something, it'll be available online. I believe we're going to have a YouTube channel. The students know how to do that. I don't know how to do that. And it'll be free, and we'll send that out. So if you're on the email list, you'll be able to get that, as well as the slides. Dr. Islam is willing to share his slides. So I saw some people taking pictures, which is totally fine. But we'll send those out if you're on the list. You can dive into those studies and review anything if you want afterwards. So over to Dr. Islam for some questions.
We don't need that. You can turn it off. No, sure. I didn't see. We can go right there. If it works.
Does this work? Okay. My question is, if we're fasting overnight because we're sleeping and our blood sugar is going up, isn't it reasonable to think that when you start eating again, it's going to go up some more? And how do I not lose weight? Because I can't afford to lose weight. So how do I fast and not starve to death?
Yeah, that's a good question. So the study that I showed that talked about delaying breakfast, that was done in individuals with type 2 diabetes. So these individuals would also experience that rise in blood glucose over the night. But it did show that if you delayed the first meal of the day, it did significantly reduce the blood sugar response to that first meal. So if you do have your breakfast at 9 or 12 p.m., 9 a.m. or 12 p.m. as opposed to first thing in the morning, your blood sugar response will be lower compared to if you had it as soon as you wake up.
And would I eat the same amount of food in a shorter period of time?
Yeah, in that study, they use the same breakfast meal for all 3 conditions. So the early, mid, and late breakfast, it was the same meal. So the blood sugar response to the same meal was reduced when the meal was ingested later in the day. So if you delay the meal, it'll result in a lower spike in your blood sugar. And your second point about not being able to, or not wanting to lose weight, so as I mentioned, there are some important benefits that result independent of weight loss, and you can still make sure that you're in energy balance in the feeding window, right? So you can eat as many calories as you need to maintain your body weight in your feeding window and still undergo periods of fasting.
A shorter period of time.
Yeah, exactly. one at the back there.
Thank you. I wanted to, you don't mention sugar at all, and you say unrestricted eating. We all know that sugar is poison to diabetics, basically. So what are your thoughts on that, please?
Sorry, if I understand the question correctly, you're asking, do you have to restrict sugar specifically, or?
Well, just in addition to when you're eating all those calories that you want,
Sure.
you still not eat sugar.
Yeah, I mean, you don't have to eliminate sugar completely, but certainly eating a lower carbohydrate, higher protein diet will be more beneficial than eating a higher sugar diet during that feeding window. And as I mentioned, eating a low carbohydrate and higher protein diet can actually have more satiating effects too during that feeding window, so it can keep you fuller or make you feel fuller for longer. So certainly I don't mean fast and then eat whatever you want over that feeding window. You still have to be reasonable, and certainly if you're living with type 2 diabetes or type 1 diabetes, you should be mindful of how much sugar you're ingesting.
Thank you.
Hi, I think I have the microphone.
Hey.
Hi. What is the minimum number of hours to get us into ketosis?
Yeah, so that's a good question. So when you do an overnight fast, ketones are detectable at very, very low levels. So I would say a minimum eating, it kind of depends on what your last meal was. Was that a low carbohydrate meal? Was that a high carbohydrate meal? How many calories did you have? Because really you're going to enter ketosis when the stored carbohydrate in your body starts to kind of run out. So that will vary depending on what you ate, when you ate, what was the composition. But yeah, generally 8 to 12 hours, they're detectable at very low levels. But to get to 1, 2, 3 millimolar levels, that would take several days of fasting. But certainly you can adapt to the kind of diet too, right? So if you're doing fasted repeatedly, your body will be able to switch between glucose and ketones faster. So you might be able to enter ketosis quicker if your body's used to switching between glucose and ketones. But it depends. Yeah, and if you're also exercising, that can accelerate ketosis, right? So when you exercise, your body releases fatty acids, you break down those fatty acids, and they can get converted into ketones. So if you're fasting and exercising, that could accelerate how quickly you see an increase in those ketones.
Exercising during the fast?
Yes. Or yeah, even if you're fed, you will increase levels of ketone in your blood. But we're talking about fasting here, so yeah, if you combine exercise during the fast, you're going to get into ketosis faster.
Hello?
Yep.
You mentioned high protein to break the fast. Could you give us some examples of what food
Sure.
is classified as high protein?
Yeah, it really depends on your dietary preferences. There's various choices. So if you eat meat, certainly steak, chicken, fish, things like that. If you don't eat meat, lentils, things like that. So it can vary depending on what your dietary preferences are.
What about yogurt and
Yeah, yogurt is good too. Yeah, yogurt, cheeses, those are all excellent sources. Yogurts, I would be cautious. Some of the yogurts have a lot of sugar, especially if they're flavored. So I would go for a lower sugar option when it comes to yogurt. But yeah, those are dairy sources are also a great high protein meal that you could have when breaking a fast.
When you're doing the fasting, delaying your meal till, say, noon, what do you do if you're taking medication that says to eat with the medication? How do you get around that?
Yeah, so again, we're not medical doctors, we're PhDs, so not real doctors, but we're smarter than most doctors though. So yeah, so again, with consultation with your physician, you can either, if it's okay for you to do so, you can delay your medication dosage by a few hours. I don't think that would have a huge risk associated with it, or you might need to modify your medication schedule completely. So again, that would have to be done in consultation with your doctor. So don't start delaying your meal by 4 hours now if you have to take your medication first thing and it requires you to eat. Yeah.
should or shouldn't exercise? Is it after you eat, before you eat?
Yeah, so the short answer is any exercise is better than no exercise in terms of blood sugar control. So exercising after a meal is good because that's when your blood sugar spikes, and exercise reduces blood sugar independent of insulin. So when your muscles contract, they suck up all the sugar in your blood, even when there isn't enough insulin being released by your pancreas. So exercising after a meal is good. Most of the time you don't want to go for a long, strenuous exercise bout after you eat. So even something like a brisk walk for 15 minutes, 20 minutes or so is effective at doing that. Doing the stairs. John mentioned exercise snacks. They're a great exercise where you do 1-2 minutes of stair climbing or some kind of hard exercise to get you huffing and puffing, and that'll help lower your blood sugar. But even if you do exercise fasted before a meal, that is shown to reduce blood sugar responses to the subsequent meal. And then there is some research to suggest that exercising in the morning might be better for individuals living with type 2 diabetes. And again, goes back to the idea that blood sugar creeps up overnight, peaks in the morning, and then your response to that first meal of the day is exaggerated. So in the morning, after breakfast would be the ideal time maybe, but any time of the day. The cool thing about exercise is that the ability of exercise to improve your blood sugar control lasts for up to 2 days after the individual exercise bout, right? So it doesn't really matter in the end if you exercise in the morning or night, you're gonna have those benefits for the next several days. So even though I talked about diet today, I'm a stronger believer in exercise than diet.
I'm a type 2 diabetic and I'm on insulin, and I'm interested in doing this because I don't like to eat breakfast very early either. So I typically don't have breakfast till between 9 and 10 o'clock. I could probably extend that to noon, but that means I'm going to have a later meal. So maybe 8 o'clock, maybe 9 o'clock, somewhere in there, and that would make my fasting window 14 to 15 hours. Is eating later though counterintuitive to weight loss? Because I mean we've all heard that eating late is not good for people who are trying to lose weight. And the other issue that I have is if I'm doing this often, because I exercise too, I will have a low in the middle of the night where I have to have a glass of juice or something like that. So, and I'm going to consult with my physician before I undertake this. So I'm probably going to need to adjust my insulin for my evening meal especially. Does that make sense?
Yeah. So certainly it would probably require some adjustment of your insulin dose if you want to extend that overnight fasting window. But in terms of the early versus late eating window, so in terms of weight, what it comes down to is calories in, calories out. It's kind of mathematical. It doesn't really matter so much when you're eating those calories. So weight is another issue. But in terms of overall metabolic health, there is some research showing that eating earlier in the day might be better than eating later in the day, so closer to bedtime. And it kind of makes sense, right? If you ingest a bunch of calories late in the day, you're not going to expend those. Your body's going to take them up and store them. And if your adipose tissue or your fat cells are already at capacity, that fat is going to go into places where it doesn't belong. So yes, there is some research to suggest that earlier eating windows are better than later eating windows. And yeah, certainly I think your insulin dose probably would require some adjustment if you're wanting to increase your fasting window. One at the back, yeah.
Been type 2 diabetic for about 5 years, and just my experience, I've tried intermittent fasting, and my blood sugars don't tend to come down, but I've also tried just straight protein, and that seems to work for me, so I'm just wondering your comments on that.
Yeah, so again, there'll be some individual variability in what works for the people in these studies. On average, might not work for every single individual in this room. So that's kind of what you have to try different things. But your point about protein, so eating a higher protein meal will typically delay the absorption of nutrients in your GI tract. So if you ingest a meal that's higher in protein, it will spend longer time in your gut. And as a result, the release of sugar from that meal is going to be slower. So that's probably why you're seeing a beneficial effect of a higher protein meal on your blood sugar levels. And in terms of the fasting not greatly impacting your blood sugar. It might require some adjusting of your, you can try an earlier window. I don't know what your intermittent fasting protocol is or was, but might just require some playing around with to find what's optimal for you. But yeah. Yep, in the back.
Yeah, this has been mainly metabolic and glucose level focused. I'm wondering, fasting alternating with that unrestricted eating, if there's any other data about general nutritional compromises or anything, because I could imagine unrestricted eating could be like a free-for-all for other food intake that isn't most nutritionally optimal.
Yeah, certainly, like you have to be mindful in your feeding window what you're ingesting, and it's not just like you can go to McDonald's 3 times a day because you fasted twice a week. So yeah, you certainly have to be mindful of your dietary intake. But the cool thing is that a lot of these studies that I presented where they did intermittent fasting, they weren't given any specific advice on like what to eat during the fasting window, but they still ended up restricting or lowering their total caloric intake because of those fasting windows, whether that be time restricted eating or a few days per week. So I think it just spontaneously results in a decrease in the amount of calories you're taking in, but certainly quality of calories also matters, right? So if you can, I would opt for whole foods and nutrient-dense sources as opposed to more processed foods during your feeding window. Certainly the fast doesn't give you a ticket to do whatever you want. Yep, one at the back, and then one at the front here.
Are you familiar with some studies that have looked at intermittent fasting for perimenopausal and postmenopausal women and how those effects are different on that subsection of people, rather than the ones, of course, done on men?
Yeah, I'm not personally. I don't know if John is, but I mean, that is an understudied population, just females in general, in a lot of biomedical and physiology research. So I think there's probably not much data in post versus premenopausal women that I can think of the top of my head, but certainly an area for more research.
All but one of those studies had men and women.
Yeah. So most of the large clinical trials do have, they have women in them, but they're not explicitly comparing pre versus postmenopausal and what might be better for one than the other, but yeah. So no one's looked at that question specifically, but it's a good idea. I think we had one at the front here, yep.
Hi, I know that you're talking mostly about health benefits to do with type 2 diabetes. What other kind of health benefits from things like intermittent fasting or maybe even long-term fasting? I'm thinking of things in terms of prevention of cancer and things like that. I've done some reading about that and wondering what your thoughts are on that.
Sure, yeah. So if we go back to this slide here where I talked about, so this is from the calorie trial, largest calorie restriction trial to date. So many of the benefits you see on this slide here, so everything from cognitive to mental to cardiometabolic to changes in body composition, a lot of these benefits would be similar with intermittent fasting because, again, the premise of the diet is still to restrict your calories. You're just doing it through intermittent periods of not eating rather than continuously. And certainly markers of inflammation and cancer-related markers are also reduced in this trial. So I would expect the same benefits to happen with intermittent fasting. Whether or not there's high-quality studies like the ones that I presented today looking at blood sugar control, whether those also exist for some of those other markers, I don't know, but I would expect the benefits to be largely similar.
And are benefits more so with more extended periods of fasting, or
like within a or just
48 hours to and beyond, just like longer fasts? Is there?
Yeah, that's a good question. I don't know if there are many studies. There are certainly studies comparing different fasting windows and how these benefits might differ. But off the top of my head, I can't say one protocol is obviously better than the other. But again, the longer you're in the fasted state, the more that metabolic switching occurs. But I think switching between fed and fasted states is also important, right? So, and the longer your fast goes, a lot of individuals will start to get cognitive effects and stuff, right? So I do think there's something to repeating altering between fed and fasted states that's good with these diets. Metabolic flexibility is what they call it. So Yep.
So most have heard the idea floated that how intermittent fasting works is it's a more like palatable way to have calorie restriction, and maybe like ketosis helps with that rather than ketosis actually making these metabolic changes. But you're the expert. What are your thoughts on that?
Sorry, in terms of ketosis impacting
Like,
your...
do we know if intermittent fasting works because people have an easier time calorie restricting, or do we know if it has to do with ketosis? Is it not clear?
Yeah, it's probably a combination. So certainly the calorie restriction piece is a big component of it, but the increase in ketones is probably also important because ketones are another fuel source for our brain and other tissues in our body. But as we're learning more about ketones, we're also learning that they have other properties to them, that they can alter different pathways in different cells and tissues and make tissues work differently. So certainly there's probably some effects of ketones that are, we're just starting to discover now that contribute to the benefits of intermittent fasting. But I personally think most of it is a calorie thing. You're restricting your calories, and we know from the calorie trial and the studies in those animals, right, that show that it extends their lifespan, that I think calorie restriction is the key to these diets. And the other things help. Certainly ketones are one. There's other things that happen during fasting that contribute to the benefits, but I think caloric restriction is a key aspect. But it's a good question. Yep.
Yeah, my questions are regarding the study you're quoting there. You said it was a large study, 75 people.
This one?
Yeah, no, the initial one that you said you had 3 control groups.
Oh yeah, okay.
Okay, so my question is a couple questions. Where was it conducted? Was there a control group as to demographics in the group? Was there, what was the duration of it?
Yeah, so this particular study was 6 months in duration. And there was a control group, and the demographics of the 3 groups, like in terms of sex, ethnicity, body mass, stuff like that was relatively similar across the groups. And a lot of these analyses that these researchers do, they can kind of account for a lot of those factors. So they call them traditional risk factors, like smoking and all that stuff. So all those things are considered when they're calculating or doing their fancy statistics in these studies. So yeah, hopefully that answers your question. This study was out of the States. I can't remember exactly where, but do you remember where Kristen Verratti's from?
I think Harvard, probably.
Yeah, a lot of these studies that I presented are from the States, because that's where some of the biggest and best, most well-funded research institutes doing medical research are. So, yeah.
In addition to UBC.
Yeah, other than UBC. Yep.
Hi, Doctor. Thanks for taking our questions today. I have a rare metabolic disease that is genetically inherited. How should it's a challenge that I don't convert ATP into energy. So it's a real challenge for me with my type 2 diabetes. What do you recommend in intermittent fasting with a disease like this, that it's a real challenge?
Yeah, thank you for your question. Unfortunately, I would have to know a lot more about the condition to be able to make any sort of advice. So maybe you can chat after and I can learn more about the condition and make some recommendations. But yeah, I can't kind of make any kind of blanket recommendation right now. So there's a lot of factors that will come into play when coming up with a fasting protocol or something. So perhaps we can chat after and I can learn more about it.
How should I approach it?
Yeah, so that's what I can advise you on, perhaps, if I can. Yeah, thanks. Yes?
The 8-hour eating and 16-hour fasting. By the time you go to bed at night, you have to take a statin pill.
Mm-hmm.
I would imagine a lot of people do. You just go ahead and take that. That doesn't interfere with the fasting.
I can't confidently say that. That's a question for your medical doctor.
But in other words, go ahead and take the medication.
If your doctor says so, you will have to ask them. Okay, I think we're running out of time here, so we're happy to chat afterwards, myself or any of the other researchers here. But thanks a lot for coming, and thank you for your questions.